All right, good morning, everybody. Today we're going to talk about design patterns for efficient DevOps processes. So for those of you who do not know me, my name is Rebecca Fitzhugh, and if you could not tell by my very American accent, I live in Los Angeles. This is not my first DevOps days in Israel, though, nor my first time in Israel. I'm lucky to have worked in Israel for about 3 years, so I commuted back and forth from Los Angeles to Tel Aviv about 10 to 12 times a year for 3 years. So I'm very familiar with the airport, security. They very much love me. And you see that magic? Like I have powers, I guess, from flying to Israel so much. So I work for a company out of Silicon Valley called Rubrik. So I'm going to try and keep this as high level and not specific to my company as possible, but there are a couple of things that I want to point out that we're doing that I've learned that have made our processes a little bit more efficient. So first thing, we're focusing on patterns, but a lot of times when you see presentations about DevOps, or at least the ones that I see in the US, they a lot of times focus on anti-patterns. I'm not about that. Right? Because when we talk about patterns, these are good things. These are good practices that we should be doing, that we want to be doing. And then anti-patterns are like, please don't do this. It's a really bad idea. So instead of having a 20, 40, however long minute presentation where we talk about all the really bad shit, how about we focus on the good stuff? Yeah. This is going to be divided into 4 parts. So we're going to look at value stream mapping. We're going to look at release engineering, test automation, and change management, everybody's favorite topic. Right? So who in here is familiar with value stream mapping? A couple of people. Who in here actually practice value stream mapping? All right, a couple of people. So at a very basic level, value stream mapping is a tool to help you eliminate waste. Right? So the goal is for you to map out what everything looks like right now from a product standpoint in terms of engineering, and then figure out where your bottlenecks are. And then that gives you an opportunity to then figure out how you can alleviate those bottlenecks and make a more efficient process overall. This is not something that we magically came up with as a part of DevOps. This is something that's been around for actually a very long time, but it was always a part of manufacturing, right? So has anybody heard of things like Toyota Kata, like how Toyota, right? So this isn't new, right? This is something, actually, when I did a similar presentation to this in Detroit, Michigan, in the US. And in Detroit, this is where they manufacture a vast majority of American cars. And when I talked about like release engineering and I talked about test automation and stuff, they're like, but I was talking about value stream mapping. They're like, we actually know this, right? Because it was all about manufacturing. So if, for example, in the very first line, the very first process takes a minute to do, and then the second process takes a minute to do, that we can do effectively one thing per minute. But the problem is like for the second example, if we're doing 4 things in 1 minute, and then the next process that happens after that can only do 1 thing per minute, we now have a bottleneck, right? Because things are going to stack up, because things are now hitting point number 2 faster than point number 2 can process them. So what do? Well, either we need to be able to do 4 things per minute on both sides, or we need to be able to do 1 thing per minute for both steps, right? So what does this look like from a software engineering standpoint? So this is a before. There's some things in there that you're probably familiar with. We all use Jira, right? Yeah, Jira. Confluence, right? So shout out, I guess, to Atlassian a little bit. But the first thing is like, what are we trying to develop? What is the use case? What is the story? All the way to the end of, is this a qualified build? Yes or no? Right? So this walks through the process here of doing analysis, doing exploratory research on what we're going to be engineering, what we're going to be developing. What are the requirements for me to write this integration of my product to, say, Amazon S3? What do I need to do, right? I need to gather that information and figure out from a software standpoint at that point what I'm going to be doing. We move into test repository, gap analysis, feature test case development. Then we start getting into testing. We can do unit testing, functional testing, end-to-end testing, right? And we just keep moving along. What happens if we find a bug? We file a Jira ticket, and then what? We fix the bug. So I didn't see a lot of hands in here that say that you use value stream mappings. That's okay. That's actually a good thing, I think, in a way, because people who are very, very familiar with value stream mappings, they focus very much on the symbols. I don't care, right? About the symbols. It doesn't have to be the most perfect value stream map that uses all the exact symbols and all the right things. So what does a triangle mean? Map out your process first, and then figure out how long it takes to do each of these things. And you're going to find that there will be certain processes, like for example, functional testing, where you might go, it sits at a functional testing state for 4 weeks. That's a problem. That's a problem for example, the company I work for, when we're pushing out releases monthly and major releases every quarter. Right? So we can't sit there in a functional testing state for 4 weeks. So we need to figure out how to fix that. Right? And so for the example, this particular example, we eliminated all of the things that have the triangles next to them because that's where we identified that there was a bottleneck. So this is actually the end state. Now this is not the most clean, simple example, but this is a realistic example. Right? So notice that the main line here, we cut it through. So we sort of dropped a lot of that additional testing and came up with a more automated and sophisticated testing process. Right? And so then from there, hey, if we do actually run into a problem during the testing process, then we're going to shoot down and start doing some of these sub-steps rather than requiring these steps in the first place when the vast majority of our testing doesn't require that. Why go through that process? Right? That's not very efficient. So we cut that out and made that optional. Right? So that's what you're seeing down at the bottom. Because hopefully, like for example, fixing a bug, hopefully bugs are not in every single release, right? Or thousands of bugs. Hopefully that's a kind of an anomaly, but we know that that's not always true. So when we talk about value stream mappings, how can we make them more efficient? So for me, one of the things that I have found to be very, very beneficial is to actually start at the end and then work my way back to the beginning. I find that when I work from beginning to end, that I get very lost sometimes in all of the sub-steps and some of the, well, here's what we could do, and I lose track of actually going from start to finish. So by me starting at the very end where I go, okay, great, we have a qualified product. Well, how do we determine it's qualified? What kind of test did we do? What about the release engineering piece of that? What came before that? Did we do any research? How do we even determine that this was a use case? So if I work backwards, I'm able to more adequately put together an accurate value stream map. The other thing is don't rely on information gathered by somebody else. I know that sounds very like I don't trust other people, but that actually skews a lot of times information. Where we say, well, on average, for this type of engineering or this type of product, it takes a week. Well, I don't want to work with an average. Right? I want to work with a very accurate number. So you have major releases, you've got minor releases, you have everything in between. Create a value stream map for each. Right? Measure what it takes for each of those different options. Right? And then, of course, make sure you are going door to door. Make sure you are then measuring between each thing how long it takes. So now that I'm finished and I move it over to there, it takes me 5 minutes to do this process, but then it goes to the next person and it takes them 5 minutes to do the next process, but in between it sits there for 24 hours, 48 hours. We want to measure not only how long does the process take, but how long does it take in between those processes actually occurring. Okay. So the next thing, release engineering. Anybody in here already doing some release engineering? Yeah? No? You guys are just like, talk faster at lunch. Got it. All right. So the goal is to accelerate the path from dev to ops and vice versa, right? And of course, ops to dev. That's our goal here with release engineering. So this is the process, right? Can we all agree that this is the process? Very simplified. Check out code, compile, test, release. That sounds right. Yeah? Is it realistic? I like it. Nope. Okay. What about this? Is that a little bit more realistic? Closer. All right, fine. Does that look a little bit better? All right. So we have a process in place. What do you guys think is the most important part of this? I feel like most people here would probably argue deployment. Yeah, is that what you guys think? Deployment? Any alert and monitoring? You know, anytime I ask that question, I say, what's the most important piece? I'm always going to, if alert and monitoring is a step, I'm always going to say that that's the most important in my perspective, right? Because how do I know that it's actually ready for deployment? Somebody can tell me, but how do I know that all of these steps have actually been gone through? and worked, right? So I'm always going to vote alerts and monitoring. So we know that this is a little bit more realistic. It's not beautiful. It's not very efficient compared to, say, the very beginning, but it's fairly accurate. Now, the thing that I want to point out when we talk about release engineering is something called the Cinefin framework. Has anybody ever heard of this? Cinefin framework. Okay. So again, not something brand new, not something that's just came out because of DevOps, but the point that we want to always make is that we need to address human factors. And if we make an overly complex system or an overly complex process, that's going to make it harder for us to manage and harder for us to actually execute, thereby making the human factor even more of an element that could go wrong, right? So we're talking about patterns. We equate patterns to effectively best practice. So the best thing that we can do for any process is always going to be make it as simple as possible. So ideally, if we can simplify, we should. Because when it comes to architecture, whether that be software or infrastructure, so this I would say applies whether you're on the dev side or the ops side, or just the DevOps, that it's all about simplicity. Because complexity is going to make it harder for it to be reliable. If you have a very complex process, you following it to a T becomes nearly impossible. So you always want to make sure that it is as simple as possible. So if we can get back to this, that's what we want to do. Right? So if we can roll up in those steps into sub-steps to one thing and make it more iterative, that would be better than having 55 huge steps. Right? So where does this all come in when we talk about DevOps? CI/CD. Right? CI/CD. So if you're not talking about and thinking about and using continuous improvement, if you're not talking about thinking about doing continuous delivery, I'd be a little bit worried. I recently gave a keynote speech at a conference in the US that was very infrastructure focused. And I stood up there for 60 minutes and I told infrastructure guys that they were doing everything wrong. They didn't like that, as you can imagine, because they don't think about things like this. We talk about infrastructure as code. We go, yeah, that makes sense. But then people who are living and breathing and they only do storage for a living, or they only do networking for a living, we start talking about codifying that and using pipelines and using workflows. They're like, what? Right? So we need to do this on both sides of the fence. And we absolutely need to be doing it. So this shouldn't be something that is a surprise. Canary. Is this something that we're all familiar with? A little bit? Okay. So back in the good old days, just kidding. So the Industrial Revolution, that was a thing. And so when we talk about coal mining, what used to happen in the 1800s and early 1900s is they would actually drop birds into coal mines. And if those birds came back up, they were like, oh, okay, we can go down there as humans. And if the birds didn't come back, they were like, they must be dead. We shouldn't go down there, right? So we talk about canaries. We actually can do this with software as well. So the idea here is that we effectively roll out updates and releases to, instead of everybody at once, to a small number of users. That way we can catch certain problems, because realistically, because the next thing we talk about is test automation. And we're going to, with test automation, try and accommodate for every single factor, every single operating system, every single version. But we might miss one, right? We might miss something. That's the realistic stance here. So by taking a small group of customers, right, say 5%, push them the new version, let them play with it in production, and then see what happens. That sounds a little bit scary, but that's a lot better than potentially pushing this out to everybody after running all of your tests and going, it's good. Still go through your tests, please, right? But then once you validate and you say, I think that it's ready for prime time, I think it's ready for everybody, don't actually give it to everybody. Right, so this is something that we do at my company. We actually, when we announce a release, we then go into EA, right, early access, and we choose about 5 to 10 customers that have applicable infrastructure for whatever it is that we just engineered for. Right, so for example, we just released integration with Google Cloud. So we had several customers that have been asking about Google Cloud, so we pushed the release to them first. And then we did DA, where we widened that scope a little bit more to people who didn't have that specific use case, just to make sure that everything played well with each other. And then eventually we go into GA, which is everybody, right? But we definitely start with a very small percentage, because that way we can catch it and go back and fix things that our tests may have missed. So realistically, when we talk about release engineering, who in here is doing this actively right now? I expect, I'm in Israel, so I expect pretty much every hand to go up, because I know working here for 3 years that you guys are far more advanced than in the US. Because when I ask this question in the US, there's one person that's never mind. So realistically, this is something that's relatively new in the scheme of things. Is somebody whose job is to engineer releases, right? Or a team whose job is to engineer releases. So my first bit of advice for making this more efficient is honestly be patient. It's evolving, it's changing. This is still relatively new in the scheme of things. But the most important thing I think here is don't make it an afterthought. If you think that having release engineering is a good idea, start adding that into your process now. Start adding that into the workflow for idea to end product. Okay. Secondly, the goal of this is to have, and the goal of DevOps in general is to have people like the devs, the release engineers, the SREs, everybody work together. What we should not be doing is creating a code and then throwing it to the release engineer and go, here you go. But that's what happens a lot of time. I'm guilty of that happening at my company. So the goal is not to just build things and throw it over. The goal is to actually sit down and show them with intent how it should be built and how it should be deployed. Right? That way we can have this happen more efficiently. Error-prone steps, automate. But in my opinion, we should automate everything because I don't want to actually work. Right? I want to chill for 8 hours a day and just a paycheck come. But maybe that's just me. And then source control, use it. That should be kind of a duh statement. You should go, yep, that makes sense. So test automation. When I was a kid, my sister, I think I have the best sister in the world because she always bought me the coolest gifts. Where I was like, Mom, Dad, you guys suck. She's the best, right? She got me the coolest bicycle on the block. She got me a Polaroid camera, Polaroid 600. This exact one, green. I thought I was the coolest kid in New Orleans. I took a couple of pictures, so I made sure the camera worked. And then I went, I have a great idea. I'm going to take it apart. And I did. The goal, of course, was to get it back together because I was convinced that if I could take apart this camera and I knew what every piece did, that would make me a better photographer for a Polaroid camera. Okay. Turns out when you're 10, you cannot get a Polaroid camera back together, but that's not the moral of the story, right? The moral of the story is when you think about unit testing and end-to-end testing, it doesn't have to be either or. I've worked in organizations where they just did unit testing and organizations where they just did end-to-end. It can be both, right? So you can test the individual components, put it back together, test the whole thing, right? And that's what we want to do. So we want to test each part thoroughly, but then test that this camera actually works and can take pictures rather than just making sure that the spring is nice and bouncy, right? Or the mirror reflects. Okay. So what else? There's also things that you can't see that you need to be testing as well. So third-party integrations and also anything that's non-functional. And I think that we should be testing very early. Okay. So there's always the Silicon Valley philosophy that's fail fast and often. Failing sucks, but there is a point to that. I would much rather know very early in on the process that something isn't working than build everything and write millions of lines of code and then go, oh, shoot. Something's not working. Now I have to debug and figure out where that is, right? So as an example, I fly far too often. I primarily live in LAX Terminal 7 rather than in Los Angeles. And so I frequently use this website to book flights, to manage flights, to request an upgrade and then get really upset when I don't get an upgrade. And so when we think about booking a flight, the process begins with searching, right? Getting results back, expanding those results, getting more information, because the first thing I do is go, that flight time looks great. What seats are available? Because I'm not sitting in the middle, right? So I have to get all my information, and then I go, okay, this one looks good, enter my information, pay, make sure that gets hopefully securely transmitted, and then I get a confirmation where they say, yep, here's your confirmation number, and that also triggers an email to get sent, right? But realistically, all of these things tie back to some kind of application server, which goes back to some kind of database where it's storing all this information. So How do we test that? I love when you create something in PowerPoint and then you put it in Google Slides and it looks like weird on the sides. I do it all the time for work and I'm like, what? So have you seen the upside down pyramid? Right, the ice cream cone type thing. This is ideally how we want to do it. We want to start at the individual unit. So, for example, can I actually search? Do I get results back? That's probably very important to test before I go, can I pay? Right, so walk through this process and make sure that each of these things works individually. Right, move up to your component, move up to your integration to view. A lot of times, who's worked with an application? I was going to name names, but then somebody speaking earlier said that they worked for this company, so I'm not going to say it. Concur. Who's logged in and looked at it and been like, this UI is a piece of crap, right? For me, SharePoint. I don't care if you're the best SharePoint developer out there and you create the most custom UI, I still log in and I go, ugh, it's the worst. Because a lot of times as technologists, we focus at the back end. We focus on the actual technology rather than worrying about the user experience, right? So that's something that we also need to be going through. Because you don't want to see what the United website looked like before this. This is a huge and tremendous improvement. But I think, in my opinion, that it's more than just this. Because one of the things that I see a lot of times, I come from, probably similar as most of you, I come from a military background. And a lot of times when we develop applications in the military, we go, oh yeah, remember security? Huh. Department of Defense should be pretty secure, right? So let's go back and harden it now. That everything's written. And then we try and test it again. We go, oh, great, now it doesn't work. Okay, this should be a part of the entire process. Security, accessibility, availability, right? Recoverability, performance. We should be, as we're going through this entire process, testing each individual component as well as testing the whole. Are they performing? Are they secured? Right? So this is actually the test framework that we use at where I work. So the first thing begins with unit testing. And then we get into smoke tests. And we actually do smoke tests every single night in an automated fashion. And so this generates a report in Grafana that we look at. We go, cool, everything worked. And then we move into our functional tests. And we also, the application that I work for, or I should say a help engineer, for the company that I work for, it's an API-first platform. And so we just wrote a bajillion scripts. And we run these scripts in a semi-automated fashion to ensure that certain things happen. Was it able to live mount? Was it able to create? Was it able to ingest? Was it able to do these things? And then we go through the UI in a manual fashion. Going through the UI in the manual fashion, this is the only manual step in our process for the company I work for. But one of the things that we are all about at where I work is where they go, we have the nicest, easiest to use user interface. It will actually make you care about backups. I work for a backup company. Okay, backups still suck. Don't tell my employer. But we have a very nice UI. It's easy to use, right? And so we actually go through and make sure that everything is usable, make sure that everything looks right. And that's the one step that is manual before we call a release qualified. So criteria, when we talk about a test framework, what should you be looking for? Big thing is you want to be looking to make sure that you have a lot of options, right, that you can customize as needed rather than having to write and create an entire new framework every single time you want to run a custom test. It's better to have a simplified framework that can be modified. Okay? But in my opinion, always, it's going to be reports and metrics. I think that's the most important piece. How do I know that any of these tests actually work if I don't have some kind of metric to validate that it did? So uniform reporting is what I'm going to say is very important when it comes to the efficiency of test automation. And of course, having something that can be developed once and then used everywhere, right? So customized on the go. Change management. Who loves change management? If anybody's hand goes up, I'm like, you're obviously an executive. You don't work in tech anymore. You're just a boss. Change management sucks because it normally looks like this, right? I submit 1 million change requests and they never get approved. Thanks, boss. So the good thing, I think, I read a bunch of blogs a while back where they were talking about DevOps is going to make change management irrelevant. And I don't think it's going, in my opinion, I don't think it's going to make it irrelevant. I think it's just going to become one thing. So when you talk about release management, you talk about change management, I think that they're just going to become one, right? So ideally, what we should be looking at in the future is to have that change management become a part of your feedback loop, a part of your actual pipeline. So every single thing that you're doing, ideally in an automated fashion, reports back, right? And it builds this report, so by the time we're ready to deploy to production, by the time we're ready to call it a qualified release, we can no joke go and say, here's all the things we did, here's their success, approve, right? And then ideally, this is a conversation that a gentleman and I were having earlier where he said, ideally it's one person that does the approval. I agree. Wouldn't that be so much simpler? But the reality is a lot of times we still live in silos, so it's one person from each group, which means there's going to be that one guy that's like, no, right? But we go in there and we just say yes, because we've already have all the information collected via automation during our pipeline. So when we talk about how do we do more efficient change management, I think the big thing is to make it a priority, which is something I never thought I would say 10 years ago. Normally I'm like, oh, change management. But the only way to make it blend into our workflow, to make it a part of our pipeline, is to prioritize it, right? And then to automate the reporting to it. So ideally, we have a single source of truth for every change. And then, of course, integrate it into your pipeline. And then streamline processes. So if you are still using ITIL, adapt that to the modern methodology, right? ITIL is still very relevant, so you can look at like standard changes, priority changes, but how does that relate to what you're doing today, right? So, lunch. Thank you very much.